Today we're going to continue with lesson 8.3 and 8.4, multiplying binomials and special cases. Today's objective is we're going to multiply two binomials or a binomial by a trinomial. Okay, so the directions say to multiply the polynomials. Remember, we have two different methods. We can either use the distributive method or we can use the box method. It really is whatever you prefer. So you decide which one is easiest for you, and that's the method you do. So with these examples, I'm going to bounce back and forth between both of them just to make sure that if you feel more comfortable with one, that you see at least a couple of examples with that versus the other. Okay, so in this first one, 2x plus 3 times 5x plus 1. I'm going to use the distributive method. So remember, the distributive method means that I'm going to break up the first polynomial and I'm going to be keeping the second one the same. So if I'm breaking up the 2x plus 3, that tells me that I'm going to write 2x first, and then in parentheses, I want to multiply it by what I'm keeping, which is the 5x plus 1. Then I go back to what I've broken up. I have a positive 3, and that also has to get multiplied by what I'm keeping, which is the 5x plus 1. So once I've broken that up, now it's back to just, let's distribute that 2x. So 2x times 5x is going to give us a 10x squared. 2x times positive 1 is a positive 2x. Now I'm going to move on to that positive 3, and I'm going to distribute that. 3 times 5x is going to give us a positive 15x, and 3 times 1 is positive 3. I see that there are a couple of like terms for me to combine. Otherwise, my final answer I want in standard form. So I got to keep the biggest exponent first, so that's the 10x squared term. Combining my like terms, remember, do not add exponents here. That just turns into 17x. And then we still have that positive 3, and this would be my answer. Okay, if I'm looking at the second example, 3x plus 5 times 3x minus 5. This time I'm going to do the box method. So remember, with the box method, we want to count how many terms are in each. So I've got a binomial, which is 2, and I've got another binomial. So 2 times 2 tells me that I want 4 boxes here. So I'm going to create my 4 boxes. And remember, I always want my boxes being broken up with addition signs. So I want an addition on the top and an addition on the left. I'm going to use that first binomial to put on the top. So 3x plus 5. So 3x goes in the first box. The 5 goes to the top of the second box. Then my second binomial is 3x minus 5. So the 3x will go for the first box. Then I got to keep that addition sign. So that means that the negative is going to stay with the 5 in the bottom box there. Now that I've created each of the sides, I want to multiply those terms to fill in the boxes. So 3x and 3x is going to multiply to give me the top left box. So 3 times 3 is 9. X times x is x squared. To fill in the top right, I want to multiply the 5 by the 3x. So 5 times 3x is 15x. To start filling in the bottom boxes, one side is negative 5, and the top gave me a 3x. So when I multiply those, 3x times negative 5 is a negative 15x. Bottom box is going to be 5 times negative 5, so negative 25. Looking at the boxes, we have a couple of like terms that are going to be getting combined together. So otherwise, I want to write my answer in standard form. 9x squared is going to go first because there's nothing to combine there. If you look at the x's here, a positive 15 and a negative 15, well, that turns to 0. So whenever it turns to 0, we don't have to write the x's anymore. There are no x's. So no x's means don't write it, and then I still have that negative 25. And this would be my answer. Let's take a look at part C. I've got x plus 6. That whole thing is raised to the second power. So anytime something's being squared, this takes us back to chapter 7 when we're talking about exponents. That means x plus 6 in parentheses is my base. That exponent of 2 tells me that I want that written 2 times if we think about our repeated multiplication. So once I understand that it's being multiplied by itself, I can then choose either method to actually multiply. So once again, I'm going to just do the distributive. So I am going to break up the first one, and I'm going to be keeping the second one. So if I break up that first binomial, I'll want the x to be multiplied by what I'm keeping, which is x plus 6. Going back to what I'm breaking up, I have a positive 6 that has to get distributed to what I'm keeping, which is x plus 6. So when I distribute the x to the first parentheses, I'm going to get x squared plus 6x. When I distribute that positive 6 to the next parentheses, I'm going to have a positive 6x plus 36. I've got a couple of like terms. Notice that both of those 6's are positive. So standard form, keep the x squared. 6 plus 6 tells me that I really now have 12 x's. And then we still have that positive 36. And this would be my answer. Here is our last example. We've got a x minus 3 times 2x squared plus 6x plus 9. So let's do the box method here. I see that I have a binomial, which is 2 terms. I see that I have a trinomial, which is 3 terms. So 2 times 3 tells us that this time I want 6 boxes. So there are several ways for you to draw the boxes. I usually draw the boxes where I'm going to put the trinomial on the top of the box and the binomial on the side. So that's why when I'm making my 6 boxes, I've got 3 boxes on the top. Remember, everything's being broken up with addition signs. And then on the side, I have 2 for my binomial also being broken up with an addition sign. So the 2 terms are going on the left. So the x and the negative 3. So the x, and then remember, the negative stays with the 3. And then I'll put the trinomial on the top. So the 2x squared, that positive 6x goes in the middle, and then the 9 is the last one. Okay. If you put the binomial on the top, that's fine. Then you would just think about it rotated. So then you'd have more of a vertical box than a horizontal box like I do. I'm going to multiply. So x times 2x squared is 2x to the third. Because remember, when you multiply, we add exponents. Then the x is going to get multiplied by the 6x. Well, that turns into 6x squared. The x also has to get multiplied by the 9, and that turns into 9x. Moving on to the bottom row. Now the negative 3 is going to get multiplied by each of those terms on the top. Negative 3 times 2x squared is negative 6x squared. Negative 3 times 6x is negative 18x. Negative 3 times 9 is negative 27. So remember, I want to start looking for like terms. I see that there's an x to the third, but I don't see any other x to the third. I actually see a couple of x squared terms, so I know I'm going to combine those. And I actually also have a couple of x terms, so I'm going to combine those as well. So writing it in standard form, since nothing combines with a 2x to the third, that goes first. If I'm looking at the x squared terms, I notice a positive 6 and a negative 6. So because those are opposites, that's going to turn into 0. Those cancel out. I don't have to write x squared. I've got a 9x and a negative 18x. So when I add that, it gives me a negative 9x. And then there was a negative 27 that I couldn't combine with anything, so that's also a part of my answer. Okay, had you decided to do the distributive method, you'd still break up that first term and you would keep the second term. So that means that you would just have a monomial getting distributed to a trinomial 2 different times, but you should still end up with the same answer.